Thank you very much for coming. Just as a starter, how many people came because they just saw it advertised on Twitter about 10 minutes ago? Right, so take that, social media. Now, here's some footage I shot down the Antarctic. It wasn't a force 10 gale, but it was a force 9 gale. And I was lucky that I was one of the few people who didn't get seasick. I used to, but not anymore. Okay, so let's just sort of roll into it. Here we are at the University of Sydney, very fine university. And there's a saying in the field of knowledge, you know, the map is the territory, the map is not the territory. And often from a map, you can get a really good idea of what's going on in the world. So this map from 1920 shows Australia's place in the world, where basically we grow wheat. But if you look a little bit deeper, you'll see that we also grow sheep, except in that middle part of Australia where there's no sheep. Repeatedly, over and over, no sheep here, no sheep there. Darwin's there, Alice Springs, but no, that's not important, only sheep. Now, over here we have a different sort of map. If you can work out what the white areas are, we're still good for the prize of a BMW, a block of flats in Tasmania? Yes, you said yes, yes. Okay, so can anybody tell me what's special about the white areas on this map? Anybody? White areas, BMW, get the electric version. Tasmania's nice this time of year. Now these, yes? Oh, without sheep. Oh, he's quick, he's quick. No, look, they may or may not be without sheep, but in fact these are the only countries in the whole world that at some time the United Kingdom didn't decide to visit and like very much. And the proud tradition follows on today where basically Americans learn geography by invading a new country, which they've done once every 14 months in the last 240 years. This here, anybody recognise what this map is? These are the only countries in the world that see education as an investment in the future, rather than an intolerable burden to be somehow monetised, hate that word, to make money for the government. And to do that, you've got to give supply and demand. And as a result of supply and demand, that means that inevitably some people will miss out, and they're the so-called the bycatch, the collateral damage. So those, and for those of you who are worrying about the cost of going to university, the story with my brother-in-law is that he left his legal work and went over to Germany, where he studied for free in his master's degree in environmental governance, and then started for free, even though on his PhD, even though he is not a German citizen. So if the money's getting you down and you feel like travelling, think that that is a possibility. And then a little bit of advice about that, or this whole education thing, which embodies a lot of what is in Newton and how he changed the world. This is not a bad motto to live by. Live like you die tomorrow, study like you live forever. So party, but have a good, nice, relaxed time. Live like you die tomorrow, study like you live forever. Yeah, that's what my father told me. I'll work on that one day. So let's just see what sort of stuff Newton did. Well, here we'll go on a little journey. A rocket got launched in 1997, and at the top of it was the Cassini-Huygens spacecraft, the largest spacecraft ever built by the human race, as one of our little robot guys. 5.5 tons, the size of a double-decker bus, with 14 kilometres of cables in it. And even though we used the best rockets that we had in 1997, it still could not fly to its target, Saturn, directly, even though, here it is, that is not a picture of it flying to Saturn. We didn't have another spacecraft behind with a camera crew. That's an animation. And the way it got there was by Isaac Newton. And so you can see here that it starts off with a little green loop on the left-hand side and goes around Earth once. And then it turns into a red loop, dives into space, does something, dives around Venus the second time, goes past Earth, which is important, goes past Jupiter, and then keeps on going out. This is a phenomenon known as the gravitational slingshot. And it's all there in a book written several centuries ago. Imagine that there's just a single body in the universe, a single planet or moon or star, and it's just sitting there doing nothing. Well, you come in at the top with a certain velocity of v, and you loop around it and you come out with a certain velocity of v. Everything changes once it's moving. You come in with a velocity of v, and you can come out with a maximum of twice the velocity of the spacecraft, of the body, plus your own velocity. I won't go into it. Look up Isaac. So here's a picture. You throw a ball at a train at 30 kilometres per hour, or miles, kilometres. The train is coming at you at 50. 50 plus 50 is 100. Add your own velocity, 130. And so when we sent the Viking spacecraft on their trip to the outer solar system in 1977, they robbed energy from Jupiter and shifted the place where Jupiter would be, such that in 5 billion years, that's a fair way down the line, it'll be 1 metre different from where it should have been. That's how much energy we robbed from it. And so if you look at the graph here, you can see that it takes off. I'll just wander over here a bit out of camera shot. So you can see that it took off from Earth at about 27 kilometres per hour, went into Venus, got up to about 40-something kilometres per hour, then went into space, dropped down low, back to Venus, got high 40s, then past Earth a bit more, and then by the time it got to Jupiter, it dropped down to about 15, 10 to 12, got a little bit more of a jump, and then barely made it to Saturn. Had only 5 kilometres per second of velocity left, having started off with 27 or so, had only 5, and then did a series of gravitational slingshots, refining its orbit with hardly any fuel, just stealing energy from that giant planet. And so you can see it starts off at 27, gets to a maximum of 43, arrives at Saturn with 5, but it made it there. All thanks to the gravitational slingshot, and since then, this has been going around, this spacecraft has been making amazing discoveries. Almost certainly we will find life on one of the moons of Saturn. This moon is called Enceladus. It is a small rocky moon, entirely surrounded by an ocean of water held on there by gravity, thank you Newton, and that is then covered entirely by a layer of ice that is 5 to 15 kilometres thick, and at the North Pole the ice is thick all the way through. At the South Pole there are cracks, crevasses, and coming out through the holes, through the crevasses, water, which turns into ice immediately, and the chemicals of life, fat, proteins, carbohydrates, and hydrogen, which if you do your basic metabolism physiology 101 stuff, is important as a fuel for life. And if the hydrogen is too high or too low, there's no life there, but if it's in between, there probably is, as well as the fact we've found very fine rocks, which mean that there are hydrothermal vents. So all of this goes back thanks to our boy here, who is painted by William Blake, playing with some compasses there, and that's the old version. The new version has him with glasses and a bolt coming out of his buttocks. I'm not quite sure why. You can recognise this, the famous Dark Side of the Moon album, The Colours of the Rainbow. Yes, Isaac was the guy who came up with the idea that colour is something intrinsic to the light that falls on an object as well as the object. It's not one or the other, it's both. And by the way, just for fun, he invented the reflecting telescope. He invented it. And of course he looked like a rock star on a badass metal band, and here's his signature. And he was a bit of a weird guy. He threatened to burn to death his mother and stepfather and their house because his mother dumped him at the age of 3, fell in love with somebody else, and just dumped him with somebody else, and he felt resentful about this, so he made that sort of threat. When he was born, he was incredibly premature and could fit into a 1 litre container. He did, in fact, you hear the story of the apple landing. It didn't land on his head, but he saw it, and in his writings, and also people who are contemporaries of his talk about the fact that he saw the apple land, and it was the case of that old saying, it's not the answer that gets you the Nobel Prize, it's the question. All you have to do once you've got the question is apply the essential things, which are lab coats, air conditioning, coffee, pizza, and so forth, and then you get the answer. And his question was, why did the apple fall down? Why down? Why not left or right or backwards or forwards or up? Why down? And that really bothered him. He also had fairly unusual religious beliefs, and this is where it gets sort of coincidental thing. Firstly, he didn't accept the existence of the Trinity, the 3 bits going to make up Jesus Christ, Father, Son, and Holy Ghost. by coincidence, he was a fellow at a college called Trinity, and you couldn't become a fellow unless you were an ordained priest. And he was so good that they said, okay, you can come in even though you're not ordained, but make sure you fix up the paperwork. So he got King Charles II to do the paperwork to let him become a fellow at Trinity, because he didn't believe in Trinity and he wasn't a priest. Okay, and he spent 2 terms as a member of Parliament, and he really knew how to stick to the important stuff. The entirety of his output while he was a member of Parliament was, there's a bit of a draft in here, can you shut that window? That was it. He was probably thinking about deeper things. So he was born both on the 25th of December and the 4th of January. Anybody know why? The calendar. They're working on the old calendar. So if you know your history, there's that wonderful movie, The Hunt for Red October. And the October Revolution in Russia happened in November, because in November 2017 they were still running on the old calendar. Okay, then he went to Cambridge and got his degree there, and luckily for him, Cambridge closed down because of the Great Plague. So he went back home, and while he was at home with nothing else to do, he casually invented sort of calculus and optics and the law of gravitation. And this is a lesson for you that maybe you should cut down on the amount of time you spend watching cat videos and Snapchatting. And I know people who spend more time reading Snapchats than they would spending reading a book a month. And at the end of the year, they got nothing for it. Like, do you want to be known for being really good at being up to date on social media, or for, and then insert career of your choice here? And this is his very own personal copy of this book. There are about 250 to 400 made, we don't really know. And that's his handwriting there, annotating it away. By the way, the book that you see over in the corner, if you can divert their attention by saying, hey, look at that umbrella over there that's turned into a monkey, you could probably get $3.7 million for it. Now, I'm not suggesting you steal it. That's an incredibly rare and precious thing. That is one of the couple of hundred only first editions of Principia, or Principia, depending on Chinotto or Canotto, your call, available in the world, and it just revolutionised the world of science at the time. The English translation of it is the Mathematical Principles of Natural Philosophy. Natural philosophy being anything that you didn't understand in the world around you. From why is it raining on top of my head but I can still see clouds, all the way to where do these rocks come from, why can I talk but a chimpanzee can't? All of those things are covered by natural philosophy, and here's the name in Latin. And then he came out later with 2nd and 3rd editions in the 1700s. And in it you see that there's some graphs, and not graphs, some little diagrams. It's in Latin, as was the language of the day. Book number 1, there are 3 books it turns out. So I used to think there was only 1, but there's actually 3 books. The first one is on how bodies move in what you might call a vacuum, but also without the influence of gravity, because gravity makes things change. So he's looking at the movement of bodies without a resisting medium of some sort, and then factoring in tiny bits of that. And along the way, he reinvented calculus, which he'd done a long time ago, played with Kepler, came up with the famous oval theorem. And are there any mathematicians here? If you ever come across a mathematician, the trick to do is to say, what's your Erdős number? And if your Erdős number is 1, they've written a paper with a famous mathematician called Erdős, who was a brilliant mathematician of the 20th century, who basically lived on amphetamines and just would go to people's houses and stay there for 2 weeks until they burned him out. And he was totally unable to live in a modern world. And so it was a great honour to have Erdős, and you get a phone call saying, I'm sick of him, I'm sick of him. Can you please send, can you take him? And say, yeah, I'll take him. It's a great honour to have him. And you'd go down to the airport and you'd pick up Erdős, and he'd move into your house. And then after about 3 days of doing mathematics, you'd be in bed with your spouse late at night at 3 o'clock in the morning, and suddenly he'd come in and wake you both and say, it's raining and there's water coming in through the kitchen window, because he'd be in the kitchen having more coffee. The idea that he should shut the kitchen window didn't occur to him, but he would wake you to tell you that. And I actually got to be really good mates with the Gavin Brown here at this university, who, because I asked him the right question when I found out that he was a mathematician, I said, what's your Erdős number? And he said, 1. he had written a paper with Erdős. If you've written a paper with somebody who has written a paper with Erdős, you've got an Erdős number of 2, 3 and 4. So here's a handy hint to get in good with a mathematician. What's your Erdős number? And he actually lived here for a while in Australia with Gavin Brown until he got sick of him and booted him out. And he got Gavin into trouble. You see, Gavin used to take every Wednesday off because he realised a great truth about gambling at the races. Let me be careful with my words. In some cases, it has been alleged that gambling might be crooked, and that in some cases, the smart money knows which horse is going to win. And it's complicated. Is it interstate? Is it in your hometown? Are there people coming in? Is it a weekday? Is it the end of the week? Is it a Canterbury race course or around a week? Anyway, Gavin had, for whatever reason, thought that some of the races were crooked, and so he'd go out to the races and not know anything about the horses at all. Didn't care. And he'd just look at the odds on the board as they rolled across, and he had recognised a pattern. And the pattern was that every now and then a whole lot of money would get thrown at a horse, and the odds would change. And he'd put his money in. Didn't matter what it was, he just followed them. And so he won fairly consistently while smoking cigarettes. That's Gavin for you. Anyway, so he had Erdős at his house, and Erdős came down. He had a special dinner for Erdős one night, and Erdős came down bearing a book, a mathematics book, and he said, I was looking up this book. He didn't turn up at the dinner party because he was too busy reading this maths book. He said, look, I was reading through this book because I was trying to remember something, and I found $15,000 in it. And over here on page 43, it says, and Gavin's wife said, what other money do you have stashed around the house that I don't know about? So anyway, Isaac Newton was a mathematician, right? Getting back to that. And so he did the oval theorem, and he did all sorts of stuff that relates to the solar system. He came up with the shell theory, which says that if you've got a really big body, you can treat it as though having its gravitational influence, whatever that is, as coming from a single point at the centre by the shell theorem. And he did the 3-body problem where if you've got this body and that body in the universe, and all you have is 2 bodies, and they're just moving around and there's nothing else in the universe, you can solve that problem. Even a first-year university student can solve that. You add in a 3rd body, it makes your head hurt. And he did some work on the 3-body problem in his book. And then in book 2, he was looking at what happens to bodies as they move through a medium that resists their motion, like a boat, an aeroplane, anything that is resisting a magnetic field, gravity. And so he did the different cases of the resistances, linear or square or cubed and all that sort of stuff. He invented hydrostatics and properties of compressible fluids and wind resistance on pendulums, all sorts of stuff, very deep stuff. This book, though, is looked upon as though it's an intermediate book, not as important as books 1 and 3. And then book number 3 was on the system of the world, which I think is a charmingly modest title, yes. I wrote a book about the entire universe, and I've sold it here. It's here in pages 1 to 500, go for it. And he came up with his theory of universal gravitation, which was controversial at the time because of how he thought it worked. He came up with looking at the motion of the moon around the Earth, and realised, in fact, that the moon does not go around the Earth, that they both go around their common centre of gravity, which is 410 kilometres below the equator. Came out with the inverse square law of gravity, that it weakens with distance, the square of the distance. Just threw in stuff on the comets. And by the way, he worked out with the tides that 2/3 of the height of the tides come from the moon, 1/3 from the sun. All of this he threw. So when he did this sort of stuff, he brought together all sorts of threads that were done by this mathematician and this scientist and this guy and this guy. And he brought them all together and made them into a coherent whole. And it was so controversial, besides people having fights with him about having invented stuff beforehand, which they hadn't, of course, because he invented it. But it took about a century for people to realise that he had brought this whole physics thing into one body that now you could then expand out from. He revolutionised the field. But only about 10% of his 1 million words or 4 million words. If you look at the Newton Project, it's hard to find out. Who are you going to believe, the Newton Project or Wikipedia? Only 10% of them were off on this other stuff called alchemy. So he spent a lot of time thinking about the alchemy, very interested in prophecy, and so he went through different parts of the Bible, and as far as he was concerned, there was no way that the world would end before the year 2060. So we're safe for another couple of decades. But where the alchemy thing tied in was with his gravity. Now, there were people who were thinking about mechanics. If you have a pendulum, it's just hanging there, and so you get it with your fingers, and your fingers touch the pendulum, and you hold it here, then you let go. And so you've got something physically touching. The boat pushes through the water. The kite is held aloft by the air. But gravity, he just said, I don't make any hypotheses, and this has been interpreted in many ways. And what he was saying, in the way it's been interpreted here, is he was saying, look, for gravity to work, you've got to have this mysterious action at a distance. The moon is over there, the ocean is right here. It acts on it. How? Don't ask me, ask somebody else. Ask somebody in a couple of centuries. I'm not making any hypothesis on it. All I'm telling you is how it is. You don't like it? I don't care. That's how it is. And some people have put forward the theory that it was his belief in the occult that enabled him to come up and think, oh, okay, we can have this action at a distance, just gone from here. I am here, and something will happen over there, and I'm not making any hints about what's happening, how the energy, the influence goes from here to there. I'm just telling you what's happening. And he was right, and it took until we get to Einstein and co. before, centuries later, before we actually work out the fine details of how it works. And then he sort of did other stuff. He used his brilliant mind to become the guy who invented the milling on the edge of coins. So if you look at many coins, you'll see they've got little bumps going all the way around the edges. And those bumps are to stop people stealing the coin. So you'd have a coin of gold, and you'd get a very sharp knife, and then you just take off 1/10 of a millimetre all the way around. And then you'd pass on to somebody else. And they'd take off 1/10 of a millimetre. And by having these little bumps that could be put in only by the machines that he invented, that stopped that sort of counterfeiting. They had to do other forms of counterfeiting. But he was incredibly ruthless and brilliant. And at that time, counterfeiting took on, or attracted, I like that phrase, attracted, the penalty of being tortured for a couple of days before they killed you. And what they would do is hang, draw and quarter you, which means they strangle you for a couple of days until you sort of go unconscious, wake up, go unconscious. And then they cut you in a big X here, pull your guts out, show your guts to you, present them to you, and then get one horse tied to a rope on each arm and leg, and then pull you to pieces slowly over 4 days. And anything that's left, they hang off a gibbet. And this was the crime for counterfeiting, and people still did it. And using his brilliant mind, he actually went underground like the Phantom. Anybody else read the Phantom comics? Am I the only one? Okay, Phantom. He'd go underground. He actually disguised himself. This guy who was the president of the Royal Society, who had received a knighthood from Queen Anne, who was one of the most brilliant minds in the whole world. When he did something, when the mathematicians would have conferences, they'd have competitions, and people would mail in their solutions. And he would mail in his solution anonymously, and people would say, the lion reveals itself by its paw. They could see the way he'd solve the problem, just elegantly, straight down the line. And other people would do 50 pages, he'd do 1.5 pages, Newton again. So he was this incredibly brilliant mathematician, and for decades, he would dress up and disguise himself as a poor person and go into the bars and the taverns and sniff around for information. And then he'd deliberately gone to the trouble of getting himself registered as a magistrate in 100 or so counties in the United Kingdom so he could carry out cross-examinations. And then he did 100 of these at least, and 28 of them led to convictions of people. And there are stories where he makes a bargain with people and then goes back on the bargain. And they go through 4 or 5 days of torture before they get killed. So that's that complex person called Newton, who gave us this book that we have here, worth $3.7 million, and he's buried in Westminster Abbey, and he's reclining with his right elbow on a bunch of books, and as is the wont of the day, with his right hand casually waving at a parchment held by some angels, saying some things about it. And his final words were very deep. He said, "I do not know what others think of me, how I appear to the world. But as far as I'm concerned, I'm just this little kid playing down at the beach. And every now and then I find a stone that's shiny or pretty, and I get lost in it, and I ignore that vast ocean of truth ahead of me." And so, even though he was one of the premier brains of all time, he still regarded himself as just having tried to dabble with the truth. He also had another strange thing where he would write out his sins. And so if you go looking, there's a list of the sins that he had committed by the time that he was 19. His first sin was that he made a feather on the Sabbath day. He apologised to God. "Hey God, I'm sorry, I made a feather on thy day." And then, even worse, he denied that he did it. Then he steals some cherry cobs from Edward's storer, and then he denied that. Actually, Edward's brother, he did a few bad things to him, and then he denied that as well. He also denied that he made a crossbow to his mother. I'm not too sure of the full story about that. He also felt very sorry for tying a cord on Sunday morning. I don't think it was that he just did up his trousers. I think it was making a rope that you could use for some other purpose. And even worse, this shows how guilty he was at the age of 19. He confessed, he apologised for reading the history of the Christian champions on a Sunday morning. So this guy was a truly complex man who gave us the world that we have today in so many ways. And if you go over there, you can look at the book and maybe breathe of it, knowing that you are in the presence of something that has revolutionised the world that we are in today. Thank you very much. Yep.
Do we have any questions?
Any questions, answers or comments, or on anything at all, really? If you haven't been able to ring into Triple J, now's probably a good time to come up with that question. But you can always do the standard thing of just saying afterwards, "I didn't want to ask the question in front of everybody else." That's okay. And you've probably got to go back and have lunch or something. Nobody? Yeah, one over here. Yeah. So, and we'll get the microphone so we can record you. So your question will go down forever in humanity, or until we change the recording format, which is next week, in which case it'll be lost.
Sorry, it's a personal question. Do you mind?
Go for it.
Okay. You're a very busy man. How do you manage your time? How do you devote time to writing your books and doing your radio presentations and family time?
I'm very inefficient. I have learned a few tricks along the way. Luckily, I have a job here at the university where I'm a fellow. Now, you know about lecturers and senior lecturers? There's a really cushy job called a fellow, which I have got. I'm the Julius Sumner Miller Fellow, and what it means is you don't have to do anything. And they pay you. I got a free glass of water. That's how much, right? And so as a fellow, you don't have to do, there's a better job, by the way, called a reader, which is professorial level. And once again, you don't have to do anything. So I don't have to do any administration, supervision, exam marking, paperwork, nothing. And what I happen to do makes them happy. And so a fellow, for example, could go down to the beach and see that the waves are coming in and that the tide is coming in. And then hang around for about 6 hours and then suddenly notice that the waves are still coming in, but the tide is going out. How come the waves are coming in if the tide is going out? And then a fellow can do that. So my position here allows me to have that time to do stuff. So on one hand, I try to be efficient and relentlessly brutal, but on the other hand, I'm really distractible. Like I was supposed to write book 43 a couple of months ago, and I was discussing with my wife how I should really wax the car we bought for $250, and she was saying, why don't you wait till after the book? And I came up with a whole bunch of other ideas of things that I can do. So I'm really good at procrastinating, but eventually the panic gets me and I get into it. One thing that I have done is I've put myself deliberately on a conveyor belt that demands 4 products every week. So for the last 3 years, 3 decades, I have put myself through a regime where every week I have to generate 3 stories of something weird that I have discovered in the world. And it's not just magazines like National Geographic, Nature, Science. I also read Australian Potato. Did you know that we've got a bit of a fungus thing going on in Australia? And also Circuit, the Journal of the Electrical Engineers, or the Sparkies. And so I generate 3 stories in a soft form where they're sort of floating in my head, but I've formalised them, and a 4th story which I have to write and perform on radio. And that forces me, this deadline forces me. So maybe you could have your phone say, you have to do something deep today, invent something, think something deep, or I don't know. So
Do you...
hang on, microphone came back so we can record it, yep.
Pardon. Do you hold yourself accountable to those deadlines? Say like you won't relax on the weekend unless you meet those deadlines, or is there some sort of consequence of not meeting those deadlines?
Weekend, ha! There have been many occasions, yeah, there is a consequence that there's a big hole and there's what we call in the media black air, right? You can't have black air. So you can have the situation where I have to record a story every Thursday. I'm recording, and I have to record it at 1 o'clock, and sometimes I've sent it to my producer at 10 to 1. If it wasn't for the last minute, nothing would ever get done in my case. So I have to get those deadlines. Those deadlines are locked in. Every Wednesday and Thursday, I'm on a treadmill where I'm doing the 8 radio shows, 2 TV shows, 1 audio pre-record, and then 2 Skypes with schools, science Q&As somewhere around the world. And so I go in on Wednesday morning, and hopefully I've got everything prepared, but sometimes I haven't. And then I pop out on Thursday night, unable to brain no more, using brain as a verb, not a noun. I can walk and I can talk, not both at the same time, but that's about it. I don't have a lot of brain function left. Okay, another question? Yeah, okay. Our job is to make Julie run. Okay, so here we go, yes. And if you have to run off to class, that's I can understand.
Hello. I was just wondering if there's ever been a serious study of Isaac Newton perhaps being a non-violent sociopath or psychopath. I've just been reading yesterday about a neuroscientist who one of his processes when asked to participate in a court case would be for people to send him scans with control cases in it, and he accidentally diagnosed himself as a non-violent psychopath because his own scan was in it. And I think in light of all the things, and it's an unpleasant sensation to actually ask that of someone that we actually really love, but I thought I've been reading up on Newton and some of the things that has been written about him and some of the things he's volunteered himself would be in modern day psychiatry be diagnosed as borderline or even a non-violent psychopath.
Yes, thank you for bringing that up. I didn't want to bring it up because it would have taken us beyond the 27 minutes. But yes, on average, I've written about this in one of my books, which you can find in this fine library. On average, 1% of males in this room and 2% of females have psychopathic tendencies. And these psychopathic tendencies range all the way from stealing somebody's coffee whenever you get a chance, all the way up to being a serial murderer. And what keeps people in line is, according to Steven Pinker's book, The Better Angels of Our Nature. Do read that book. It's got 2 to the 10th pages in it. They're a tough audience, 1,024 pages. Yeah, I know. And small print, but it says that we are living in the most peaceful time ever. Getting back to the psychopaths, I first came across this when I was studying psychiatry as part of my medical degree, and it didn't really make sense to me until I went into television. And to my surprise, I saw these people I recognised as having psychopathic tendencies around me. It took me a few years. I could not believe it. So I think this is actually an important second piece of advice. The first piece of advice, party like you die tomorrow, study like you live forever. The second one is, there are psychopaths around. And all you have to do, I found this impossible to believe, and you'll hear people talking to each other saying, why did this person do this to me? And if you go in there thinking, every now and then I'm going to run across one of these people, then you'll be able to live with it better. You think, oh, that person is a psychopath. And the way you deal with it in general is simply to recognize that they are and make sure you're okay and the people around you have to deal with that person. It's like getting annoyed that whenever you go out in a thunderstorm, you'll get wet. So whenever you deal with this person, at any time, you can be quite sure that they will do the dirty on you. They don't care one bit about you or your future career. You might be doing a PhD with them, and everything depends upon their appraisal of you. And if it turns out that at the end, to save their bacon, they have to dump you, they will, and not have any guilt. And so long as you realise that from the beginning and set things up so that quietly there are back doors through which they cannot escape, but you can, then you can survive better. As an example of these psychopathic people around us, I quote in my book the study that was done at a university where they filled the audience with half people with strong psychopathic tendencies and half regular university students, being the cheap economy model of a standard human, because that's what Psychology 101 does. And the job was that you had to walk in front of this audience and pretend you didn't have a £100 note in your pocket. So there was a central area, a door over there, a door over here. Behind the door, they would say, here's a £100 note, put in your pocket. Now, walk out the front, walk across, look at the audience, do anything you want, don't do anything, it doesn't matter, walk through the other door. Just don't act like you've got a £100 note in your pocket. The psychopaths, in the majority of cases, could pick who had the £100 note in their pocket. So you're dealing with people like Newton who have got an advantage right from the beginning because they are prepared to have no moral standards, right? That gives them an advantage straight away, because you will say, no, I wouldn't let down your tyres if I wanted to make you late for this meeting so that you wouldn't be able to turn up and disagree with what I was going to say. But they would. They wouldn't care. So just so long as you know that they're there and they're being kept in bay by our society. And then you mentioned the violence thing. So there are many ways of categorising, but there's a nice little 2x2 grid which goes violent, not violent, intelligent, not intelligent. And so if you're both violent and intelligent, you'll end up in the cops, in the military, in the SAS. If you're intelligent as a psychopath but not violent, hey, welcome to big business, the big end of town, and say things that you'll deny immediately. And then you go into the other grades as well. So that was a bit of a moral message there. Sorry, it's a bit of a downer talking about psychopathic type people. Sorry. Okay. Another question, but if you've got to run, we fully understand. So our trained runner, Julie, is coming towards you with the microphone. And just talking to it. Yep.
Something that's bothered me for a long time is the difference between Newton's and Einstein's theory of gravity. Now, Newton said that the force of attraction between two bodies is proportional to the product of their masses, inversely proportional to the distance between them. Einstein is much more complicated. They can't both be right. And I believe that Einstein gives much more accurate predictions. So would you comment on that, please?
Okay, so this ties back to the concept that Newton was right within the framework that he dealt, and around his time it was known by looking at the moons of Jupiter what the speed of light was, roughly. And they were saying they didn't know whether gravity travelled at the speed of light or not, but that didn't really matter. Einstein took it to the next level, and the key comes in the paper with the words "of moving bodies." Things change when you move. So with regard to Newton, Newton simply says the moon's over there, the ocean is here, bing, 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 blah, 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 inverse square law. That's what I know. Einstein took it to an extra level. one thing that Newton said that was wrong was that time and space are absolute, right? And Einstein said that no, they're not. Now I'm just going to do a little diversion and then come back, okay? So now we're entering the diversion. You've got general relativity, that's Einstein. And Einstein says that time and space are wibbly-wobbly and move around, quoting Doctor Who here. But on the other hand, everything has a cause. A leads to B. Nothing happens by itself. Let's have a look at quantum mechanics. Quantum mechanics says, hey, time and space are fixed, the exact opposite of relativity. And then it says, you don't need a cause. The exact opposite of relativity. You don't need a cause. You can have empty space and suddenly particles can wink out of nothing into it and wink away. So we've got two ways of thinking about the world, relativity and quantum mechanics, each built on totally opposing assumptions and postulates, and each of them correct. Oh my God, okay, it's making your head hurt straight away, right? So what Einstein did was say that time and space are not absolute, that they can vary. And that subtly changes things only in extreme cases. So in the world around us, no difference. In the planets orbiting the sun, no difference until you get to Mercury. Mercury is, like all planets, in an elliptical orbit, and if you assume that this finger is a sun, it sort of goes, I'm exaggerating the elliptical, so all the planets sort of go elliptical like this. Mercury goes elliptical like this, but keeps on swinging around. And the long bit of the ellipse changes. They had measured this by the time of Newton, but they could not explain it. You need the concept of time and space being wibbly-wobbly for that to make sense, and then Einstein predicted that, measured it, and it came in with these measurements. So Newton is correct, but he's a special case where you're not dealing with extreme conditions, such as high speed, or in the case of Mercury, high gravity. So they're both correct. I know it's hard. Okay. Another question? One at the front, thank you.
You were saying that Newton had psychopathic tendencies, but...
Oh, not me. It was my best friend over there who said it, and I just agreed. Trying to be friendly, yes.
But in that slide when he was confessing his sins, it seemed like he had a lot of guilt. Isn't that very unpsychopathic?
They were done, yes. We have either 1 million or 4 million words from him. And there are the confessions before he was 19, and there's about 46 of those. And then there's confessions after he was 19, and there's about 8. Maybe he gave up thinking that he was doing wrong. I do not know. I can see this as a fascinating thesis, and if you talk with my new best friend over there, you can see exactly what the psychiatrists, psychologists, sociologists have been trying to find from his work. I would find it very difficult to be involved with the process of bringing justice to the world if it meant that justice meant 5 days of torture followed by death to the person who broke the rule. I would find that a very difficult thing for me to be involved in, but he found no problems at all. But maybe that was the time of the day, because back then, as soon as a woman with money got married, she didn't become property, but all of her property went to that other person, and that got changed in 1731? Sometime anyway. So it was a different world back then. People had different ideas. So, okay, another question. I don't know too much about psychopaths. Okay. Thank you for coming.
So you just said it's a different world back then. So how should science, I guess, treat religion in that respect? Can the two coexist? Because it seems we're moving to a point where science is almost fighting with religion in some places of the world.
Yes, no, it's complex. One of our top relativity people in physics was a minister of religion and found no conflict. So, having talked to this person about how they had a whole bunch of things in their head that were based on proof and needed no faith, and simultaneously had a whole bunch of things in their head that were built on faith and didn't want any proof, they're just in different boxes. And they're like orthogonal, which is a fancy physics word for saying they're at right angles to each other and they do not intersect. So yes, I believe this thing which is totally without proof, but on the other hand, talking to me about relativity, you've got to be on the nail. So I don't see any conflict. The classic example is believed by 40% of people in the United States is that the world is 10,000 years old or less. And this goes back to James Ussher in the 1700s, who was a really smart guy and who tried, following on from people earlier, to work out the age of the Earth, and using the best data he had, which was archaeological evidence and historical writings and the Bible included the kings and who begat whom, begat whom, begat whom, and he put all of those together and he came up with an age of 6,000 and something BC or whatever, which fitted in with what other people had done using the same data. Now, just a little diversion here. If you read his writings, you'll see that he is somebody who is searching for the truth and he needs data. He just didn't have the raw data back then, right? And so from what people who specialise in this field say, that he would, given the data of today, have come up with the 13.8 billion years. Okay, after about a century, his dates for certain things, events happening in the Bible, got stolen and without copyright being paid, which already existed at that time, got put into an edition of the King James Bible. And so now you've got people who are not enormously educated, who probably can't read, but they've got a Bible, and if they can read, over here Noah does the flood and there's the date. And so they think that God put it in there, not a human, James Ussher. So overwhelmingly, from having talked to people who are scientific and who are both religious and scientific, they don't see any conflict. Maybe that's an ideal world. Where are we? Another question now?
Hi. I'm just wondering if there are various English versions of the book, and if there are various translations, is there consensus between them, the meaning of the passages?
Of Principia?
Yeah.
Principia? I'll hand that over to my colleague, Dr. Julia here. Dr. Julie. Don't know. I think it has been translated. Reading Wikipedia, it did say that there were translations into different languages, some of them illegal without copyright, but I'm sure you could find translations today. My bet would be yes, 95% yes. There you are. If you want to read it. Okay, another question. Okay, one over here now, making you run. Poor Julie, sorry.
Hi, you mentioned Newton's positions in government and finance, and I was just wondering, did Newton make any innovations in finance and economics, since he did study, I assume, those fields? To be in those positions, of course.
Number one, definitely do not know. Number two, to keep you happy, double entry bookkeeping. Who invented double entry bookkeeping? The Italian. And which Italian? Pacioli, who was the boyfriend of Leonardo da Vinci when they were on the run from war in Venice in the 1500s. So there you are. Double entry bookkeeping was invented by Leonardo's boyfriend. There you are. So I couldn't answer the question that you asked, but I did try to help a little bit. And so double entry bookkeeping is if you sell me your bicycle for $200, you've got 2 books, and one of them is how much money you have, and the other one is how many bicycles you have. And I've got 2 books, and so that's kind of there was a version of it around, but Pacioli brought it. How do you pronounce his name? Pacioli. Pacioli. It was in Venice, 1500. About that, roughly. Yep. Okay. No other question. Yeah, one over here.
This might be a little bit more philosophical, but I was reading in a book the other day that when you kind of look at metaphors of the universe, so you're looking at from an Aristotelian point of view, you're able to view the universe and the world system through a metaphor of like an organism. And then when you get to Newton, it kind of goes to the mechanistic view of nature. And then I was reading that there's been a shift through quantum mechanics, like Bell's theorem, in which there's no longer a way that we can imagine the world that we live in through a metaphor. I was just wondering if you have an explanation for that.
You have hit upon a very deep question about how the changing view of the world from the people around you affects from what you can see, and then how the scientists are coming in and saying that what you know is or is not correct. And so with quantum mechanics, you've got this really strange body of knowledge where people do an experiment, you can go and look at their experiment and you get some results, and everywhere else in science you can say, oh, well, this means such and such. But in quantum mechanics, I'll argue what the heck it means. So talking about entanglement, Bell's theorem, can information be transmitted faster than the speed of light? I think that, yes, to some degree, the frame of mind that you have alters your thinking. And so you can't see outside. And so in the case of Newton, a lot of what he did was simply synthesizing what people had brought together in bits and pieces, and he could see this and this and said, obviously they come together. And every now and then he'd have an insight that you'd think, where the heck did that come from? You got no idea. So with Einstein, with his first theory of relativity in 1905, if he hadn't come up with it then, other people would have come up with it. You know, what happens, E equals mc squared, what happens when you've got moving bodies. But his 1915 special theory of relativity, that just came out of nowhere. Nobody had any idea how that came up, and it might have taken half a century or a century for somebody to ask the question and come up with the insights that he came up with. So this whole thing you're talking about, I'm just going to bail out because that is just so deep. It's almost like it needs a drink with a little umbrella or two and several hours.
I'm writing my essay on it in like 2 weeks, so wish me luck.
Oh, the best of luck in 2 weeks. You've picked a really deep topic, which is good in one way, but on the other hand, sometimes it's easy to pick a shallower topic. I hope those examples I gave you of Einstein and Newton helped a little bit, but there are, actually, it might be worthwhile talking to some of the quantum physics people in physics, because some of them are quite philosophical. We've got 3 or 4 professors of them, and just grab them as you can and just ask them for their point of view, and they might point you in a direction where you could get some insights that could be of use to you. That's what I do. I just remember the 3rd rule of university: don't let anybody else's work evade your eyes, so plagiarise.
I think we might be out of time, I'm sorry, but thank you all very much for coming, and thank you very much to Dr. Karl.
Thank you very much.